So next part after postfix notations is the syntax tree. A parse tree is an example of a very high level intermediate representation. As parse tree contains all the information about the program that can be used to build the source code. So a parse tree has all the information about the program which is used to build the source code. A syntax tree on the other hand is a graph structure. Nodes in a syntax tree correspond to statements. Edges in a syntax tree represent relations between statements. Abstract syntax tree is used to drive the semantic processing and code generation. An abstract syntax tree or just syntax tree is a tree representation of syntactic structure of the source code written in any programming language. Each node of the tree denotes a construct occurring in the source code. Each node has reference to its parent and child node. So each node in a syntax tree has reference to its parent node and to its child node. It does not give all the information about the program. It only gives information with respect to the operator and the constants or the variables which are used or the identifiers which are used. So it does not give you the information about function list or about the program structure. That is all given by parse tree, not by the syntax tree. Syntax tree is not concerned with giving the information about the functions or about the entire source code. So let's see one example. It says that construct a syntax tree for the given string a into a minus b plus c into a minus b. So for this, first is this is your left child, this is the right child. For plus, so plus will be my root node. Plus is my root node. Your left is there and your right is there. Now in the left child, multiplication is the root. Here also multiplication is the root because it is the common operation between the two. Then the new left is this and the new right is this. Here the new left is this, new right is this. So left I wrote here a, here also I write left as c. Now right is a minus b. Operation performed between a minus b is minus. For minus, the left child is a and right child is b. Here also common operation performed is minus. For minus, left child is a, right child is b. This is the syntax tree for the given expression. Let's see the second example. Example number 2. Second example, the string given to us is a plus b into c plus minus b into a minus b. Now in this, first we will start from this expression. For this expression, plus is your root, left child is a and right child is b into c. For this, into is the common operation, left is b, right is c. Now between these two operations, plus is the common one, so plus is the common one. Left is this which we have already done, right is this. In this right, into is the common operation, so into, right child is a, left child is minus b. Minus is the common operation and B is the right child of minus. Now between these, minus is the common operation between this full thing and B. B is the right child of minus, this is the left child of minus. So minus, left child we have already done, right child is B. So here we will write B. This is the syntax tree for the given expression. Let's see one more example. Example number 3. We have been given the string as A into B plus C minus D into A into B plus B. For this, first is common operation between A and B is multiplication. Plus is the common operation between these two. So this is the left child of plus, this is the right child of plus. So I write here plus, left child is A into B. Between A into B, common operation is multiplication. Left child of multiplication is A, right child is B. C minus D, common operation is minus. Left child of minus is C, right child of minus is D. Now this is done. Into, now into, left child is this, right child is this. So here I will write into. I have already solved for left child. For right child, common operation is also into. Left child is A, right child is B. So this is also done. Now we have a plus. This plus, this is my right child for plus, and this full thing is my left child. Left child I have already done for the plus. So right child is what? Right child is B. This is my syntax tree for the given operation. Now we will see the sequence of operation for a syntax tree. What we will see? The sequence of operation for syntax tree. We will take this same example. We will take the same example and see how to do. So in this, we have to remember 3 things. The first thing is MK node. MK node is make node function. In the make node function, the parameters which we can pass is an operator, a left child and a right child. Then we have the make leaf function. In make leaf function, we can pass a number, comma, value. And in make leaf function, we can also pass parameters, identifier and entry to symbol table. Now we will do the same example using the sequence of operations of a syntax tree. Your example is A into B plus C minus D into A into B plus B. So first I'll write here P1. In P1, first we'll take A. So A is your make leaf, ID, comma, entry to the symbol table is A. P2 will be again make leaf, ID, comma, B. What have we done? Simply we have done very simple thing. We have written this as P1, this as P2, and we will pass this in P3 as multiplication. So P3 will be your make node, where your operator will be multiplication, left child will be P1, right child will be P2. So P3 will be make node function, operator is multiplication, P1 left child, P2 right child. This can be written as A into B. Now P4 will be C. MK leaf function ID comma entry to the symbol table is C. P5 will be MK leaf function ID comma entry to the symbol table is D. Let's see this. This will be P4, P5, put in P6. P6 will be your MK node. Operator is minus, left child is P4, right child is P5. So my P6 will be MK node. Operator is minus P4, P5. This can be written as C minus D. P7. P7 is also MK node. MK node. Why it is MK node? Let's see up. See, this is your P6. This will be your P7. In P7 we will have left child as P3, right child as P6, operator is plus. So operator is plus, P3 is left, P6 is right child. This can be written as A into B plus C minus D. Now P8. In P8 we will have A. We will put A in P8. Here we will put what? P8. This will be P9. This will be P10. Then we will have P11, P12 and P13 finally. So first we will do P8. P8 is ID comma A. P8 is MK leaf ID comma A. P9 is MK leaf ID comma B. P10 is MK node. MK node operator. Operator is multiplication. Left child is P8, right child is P9. So under P10, multiplication P8, P9. This will be A into B. P11. P11 will be, again P11 will be MK node. Left will be, operator will be multiplication. Left will be P7, right will be P10. So MK node multiplication P7 comma P10. This further can be written as P7 is this. So A into B plus C minus D into, and P10 is this. So A into B. Next is P12. P12 is the single B, that is your MK leaf ID comma B. MK leaf ID comma B. P13 is MK node. Operator is plus. Left child is P11, right child is P12. Left child is P11, right is P12. How will we write this? See, P11 is the left child. Copy this left child as it is. A into B plus C minus D into A into B. Then copy this operator. Plus P12 is B. So plus B. This is the entire sequence of operation of a syntax tree.